We'll try solving them, and then we will uh, look at the next topic. All right? Is that fine?
Yeah.
Yeah. Okay. All right. Let me pull up everything here. So, okay. Okay. So let's look at the sums for, and we'll not do a lot of sums. We'll just take a look at whatever we have learned. Is that good enough for doing some of the sums that comes along with the unit? And then we'll have some assignments that we can do it offline as well. Okay, let me share my screen quickly. Let me know once you're able to see it. Are you able to see my screen now?
Yes.
Oh, okay. So let's look at some of the sums. We'll try doing it together. Come on. Oh, okay. Yeah. Okay. So we have some questions on scatter plots that we wanted to try. Okay. Let's look at this question. You can see the screen, right?
Yeah.
Do you want me to make it bigger for you? Or this is okay?
That's okay.
Okay. I'm quietly reading this one. You can also read it, and then we'll try answering it. Okay. Let me make it little smaller so that you can see the question and the options also. You can see both now. Are you ready?
Yeah.
Okay. So what is your answer? And we'll kind of debate on that to see what was the approach that we took.
Um. Wait 1 second.
Mm-hmm. Yeah.
I
Hmm.
think it's. I don't know if it's either B or C. I don't think it's A or D, but
Okay. So let's look at this question again. Okay. Following the same methodology I say, right? So I'm reading it one more time. First of all, here we see. Let's look at the diagram here. Says height and width, right? is what we have on the x and y, sorry, y and x coordinates. And this is a line of best fit. That's understood. Says dimension of 12 picture frames. So every dot is representing dimension of one any picture frame. Yeah. Which of the following statement about the widest picture frame is true? First of all, we have to find out which one is the widest picture frame. Which dot is representing the widest picture frame? Widest picture frame. Which dot is representing the widest picture frame? That's the one
The
at the top, right?
yeah,
Because that's the widest, right? That is where the width is maximum, correct?
it's 20,
So the
right?
one that is, yeah,
25.
not 20, it's 5.
35.
Yeah.
Yeah.
Yeah. So that's now we have recognized which dot they are talking about. Let's look at the answers now. It says which one is true. Now we know that it is the width is 25 and height is somewhere around 34, 35, 33.5, whatever it is, right? We cannot see the exact number there, right? We can make a guess. It's below 35 and above 30. Whether it's 34 or 33.5, we don't know right now. Yeah.
Yeah.
Yeah. So
Yeah.
let's look at first one. The height of the widest picture frame is 4 inches greater than the height predicted by the line of best fit. So as I was saying, from this one we can see the exact width is 25, but height we don't know. It's 35, 34, 34.5, 33.5. We don't know. It's just a guess. Very close to 35, but we don't know. So height of the widest picture frame is 4 inches greater than the height predicted by the line of best fit. We don't know whether it's 4 or 4.25 or 4.75, right? So I'll probably park that one. A will park probably. Yeah. Height of the widest picture frame is 1 inch greater than the height predicted by the line of best fit. Line height predicted by the line of best fit is around 30, and this is above 34, close to 35. I don't know what it is, but certainly it is not 1 inch greater than the height predicted by the line of best fit. Because if we are talking about the line of best fit, that would have hit somewhere around 30, right? That's why it is cutting this one, correct?
Yeah.
So again, we can make guess, but this doesn't seem to be perfect. Now let's look at the next one. The height of the widest picture frame is equal to the height predicted by the line of best fit. That is not correct for sure, because the height predicted is around 30 and it is much higher than that, right? So C I would probably not go with. So C is certainly not looking like the answer. I mean, let's. Do you want to validate what I'm saying? Or see, C is the height of the widest picture frame is equal to the height predicted by the line of best fit. If it was the height predicted by the line of best fit, it would have been very close to that. And we don't see that being the case, right? It's far from that.
Yeah.
Yeah. So C is certainly candidate to be ruled out. D is the height of the widest picture frame is 4 inch less than the height of the okay. It's it's saying 4 inches less than the height predicted by line of best fit. That's what is trimmed here, but that's what we have in the last line, right? The height of the widest picture frame is 4 inches less than the height predicted by the line of best fit. So this is certainly not less than that. This is more than that. So C and D I would want to rule out. Yeah.
Yeah.
Now it's a question between A and B. Height of the widest picture frame is 4 inches greater than the height predicted by the line of best fit. This is 4 inches. The height of the widest picture frame is 1 inch greater than the height predicted by the line of best fit. Okay. Now it's a question between one and A and B. A says the height of the widest picture frame is 4 inches greater, and the B says the height of the widest picture frame is 1 inch greater than the height predicted by the line of best fit. Between A and B, if you see, if we go with A, it is 4 inches more. If we go with B, it is 1 inches more. But 1 inch is more is certainly not the case, right? It is much closer to 35. Yeah.
Yeah.
If I make it, let's say, 200%, and then you look at it, see, it is certainly very close to 35, maybe 34, but certainly not 31. So, my best guess here would be, see, let's look at A and B again. B says height of the widest picture frame is 1 inch greater than the height predicted by the line of best fit. This has to be ruled out. First one says the height of the widest picture frame is 4 inches greater than the height predicted by the line of best fit. That is the closest answer it looks like. Am
Right.
I? Are you with me here?
Yes.
And so so in that case, here this technique is called the elimination technique. You don't know which one is the best answer, but by reading the questions and the options here, you will probably certainly be able to rule out what are the non-valid options. So let's say if you have four options and three are non-valid, then you end up leading to the fourth option, and that's the best option actually. Yeah.
Yeah. Uncle, can
Yeah.
you give us like 2 minutes? I'll be right back.
Sure.
Sorry, Uncle, I'm back.
Yeah. Yeah. No problem. So first question you are clear about, right? I mean, no doubt.
Yes.
And see what we did was we just spent little extra time on that question. We kept reading it again and again. We kept reading the options also again. And as you would have seen, there was no intelligence involved. We were just reading the question a couple of times, and that gave us the answer for that. So let's
Yeah.
do the same exercise with this second one also. Let me make it. Let's read it first. Let's take a look at the scatter plot first, and then read the question. After a minute, we'll start discussing. Yeah, let me know when we can start. Have you read this question?
Yes. I
Okay.
I just
Hmm.
finished.
Okay. So again, same thing we'll do. And this is my scatter plot. which says on the y-axis I have average rating points, and on the x-axis I have price for the chips. Okay, so parallel is rating different kinds of potato chips. The scatter plot above shows the relationship between the average rating and the price for the chips. Okay, so every point denotes what is my rating for the given price. And then we see the line of best fit. The question is, according to the line of best fit, which of the following is closest to the predicted increase in average rating for every 10 cents increase in price? So, okay, let's see what is your reading or the possible answer for this question, and then we'll debate on that one.
I don't understand the question. Like, I get the graph, but I don't understand what they're asking for.
Hmm. So, what I'll do is I will try proving myself right by reading the question again and again. Okay. So let's do the same thing. So as I keep saying, right, when you read the question a couple of times, the question becomes easier. So that's what we'll do. Okay. So first line I will not repeat. A panel is rating different kinds of potato chips. That line is simple, right? I mean, I'll not go there. The scatter plot above shows the relationship between their average rating and the price of the chips. So if you read this line again, the scatter plot above shows the relationship between their average rating and the price of the chips. So if I pick up one dot, let's say if I'm picking up this one, or let's say the bottommost one, it says this, what is the y coordinate value for this one? Somewhere around 1, right? Maybe zero point 0.9. Yeah. I'm picking up the smallest one, the bottommost one, dot. Yeah. The rating is somewhere around zero point 0.9. And what is the price? Maybe 1.1, $1.2. Do you think so?
Yeah.
Yeah. So it says the scatter plot shows the relationship between the average rating and the price of the chips. So what we are seeing in the first bullet, I mean first dot, is that the rating is around zero point 0.9 or 0.85 and the price is $1.2. Let's look at one more dot, um, which is on the line of perfect, best line of fit. Okay, line of best fit. So let's pick another one. I'm picking up second one. You can see my cursor, right? Do you see
Yeah.
where my cursor is? Yeah. Okay, so I'm picking the second dot on the line of best fit, and that is around maybe 3.5 rating. I mean, y-axis value is around 3.5 for this guy. Do you think so?
Yeah.
And the price on the x-axis for that same dot is maybe 1.75 or 1.8 kind of a thing. Do you
Yeah.
think so?
Like 1.75.
Yeah, okay. So we'll take that and we'll go ahead. So second line we understood, says scatter plot shows the relationship between the average rating and the price of the chips. So we just picked up two dots on the line of best fit and we just tried reading it. Okay, what is the possible rating and what is the likely price that we can see from the graph? Okay, we saw two of them. Now the line of best fit for the data is also shown. Okay, so this line that we see is the line of best fit, and good that we were looking at the dots which are on the line of best fit. Now, according to the line of best fit, which of the following is closest to the predicted increase in average rating for every point $1? So if you again read the third line, according to the line of best fit, which of the following is closest to the predicted increase? Which of the following is closest to the predicted increase in average rating for every 10 cents increase in price? Do you think the last line is making any sense so far?
No.
Will I will read it one more time. According to the line of best fit, which of the following is closest? Whatever we see following, right? Point one, point five, 1, 5, whatever, right? According to the line of best fit, which of the following is closest to the predicted increase? Which is closest to the predicted increase in average rating for every 10 cents? So tell me if this line has made any sense so far. No? One more
A
time.
little bit.
A little bit. So it'll make more sense. Let's read it one more time. I'm just breaking it down. I will not read the first part of the sentence according to the line of best fit. Okay. Which of the following is closest? Whatever we see below is closest to the predicted increase in average rating. Predicted increase in average rating for every 10 cents increase in price. Now you read it reverse. What it is saying is, for every 10 cents increase in price, what is the predicted increase in average rating? Okay, I'm just reading this sentence upside down, straight, whatever. Okay, I'll just read it one last time, and then I will probably check how much you have understood and what would be my interpretation from this one. Okay, so according to the line of best fit, which of the following is closest which of the following is closest to the predicted increase in average rating? Closest to the predicted increase in average rating for every 10-cent increase in price. So there are two terms that you are coming across. Okay. Okay. Before I start saying, um, did you understand this time, or are we a little far from being clear?
So is it just asking which the following is closest to 0.10?
No, it's saying now you're getting there. Okay. It is asking you what is the predict. Forget about the word closest. Okay. What is the predicted increase in rating for every 10 cents increase in price? See, if you look at this graph, what's happening? If you look at the smallest, sorry, oops, what happened? If you look at the lowest point, here the price is low and the rating is also low. If you pick up any next point, you see the price is increasing, rating is also increasing. If you go to the topmost point, the price also has increased, right? It's almost like $2.5, and the rating has gone to almost like 9. Yeah. So by looking at this scatter plot, one thing is evident that when your price of the potato chips is increasing, your corresponding rating is also increasing. Is that a fair statement?
Yeah.
Can you hear me okay?
Yeah.
Yeah, okay. Yeah, so what I was saying was, based on whatever we have observed with this scatter plot, can we make a statement that when the price is low, the rating is low? If the price keeps on increasing, the rating has correspondingly increased. Is that a fair
Yeah.
statement? Yeah. Now,
Yeah.
if that is the observation, that is exactly what this guy is asking also. It's saying that we agree that if the price is increasing, rating is increasing. The question is, How much is the increase in rating for every increase of 10 cents? Meaning, when we say that price is increasing, when the price is increasing, rating is increasing. So they say, okay, tell me by how much? By every increase of 10 cents, how much my rating points will increase? Do you think I'm making
Oh,
sense?
so like then probably around like
Huh.
0.1 or 0.5.
So I will not do it that way. Now you have understood the question, right? How we'll
Yeah.
find the answer, that is much easier. Understanding the question is more important. So based on all the observation that we made, based on whatever we did with by reading the question again and again, trust me, I've not taught you anything, right? I'm just reading it for you. So it says that okay, I mean it made us observe that yes, by looking at the scatter plot, we see that when price is increasing, rating is also increasing. So the question is, according to a line of best fit. Now the disclaimer here to remember is according to a line of best fit, meaning whatever comparison we will do, we'll look at the dots which are very close to or on the line of best fit. We'll probably not pick up these ones which are little far. Okay, not these one, not these ones.
Okay.
Okay, so we'll pick up the points or the dots which are on the line of best fit. So let's pick up, let's say the bottommost one and the topmost one. What say? Is that okay?
Yeah.
And if I pick up the bottommost one, what is the price for that one?
It's like 1.1, I want to say.
1.1, 1.2. Okay. Can you note it down?
Yeah.
And what is the rating?
The rating is like
Point
1
nine,
point,
point nine
I think
maybe?
it's point 0.7 or point something like that.
Maybe a little more than that. It's much closer to the line. So maybe I'll give it point 0.8 maybe. Yeah. I'm talking
Okay.
about the bottommost point. Yeah. Is that okay? Now,
Yes.
let's go to the topmost point, which is also pretty much on the line of best fit. I'm talking about the one at the top. Yeah. And what is the price for that guy?
Would it be like 2.6,
2.6, 2.7. Yeah. Yeah. We'll give it 2.7, let's say. Okay. So what is the rating here?
like is that 9? Okay, so 8.8.
5. 8.5, maybe. Yeah, it's somewhere in the middle, right? If you see it closely, it looks like to be in the middle. Yeah. Maybe 2.5, 2. Sorry, 8.5, 8.6. Yeah.
Okay.
So here, what do you see? If we just look at these 2 points, okay,
Yeah.
my rating increased from point 0.8 to 8.5. So it increased by 7.7. Yeah,
Right.
it increased by 7.7 for an increase of how much price? From 1.2 to
2.
2.6, 2.7.
Yeah.
So for one, almost like 1.7, if I say 2.7, so 1 point for increase of 1.2 to 1.7, so 1.5 basically, right?
Yeah.
For an increase of price by 1.5, my rating increased by
7.7.
7, right? So 1.5 led to the increase of, or 150 cents led to the increase of 7.7. Yeah.
Yeah.
So 1.2 to 2.7, right? So 1.5, yeah. 150 cents led to increase of 7.7. So 120, sorry, how much that was? 150 cents, right? Yeah. So 150 cents led to change of 7.7. So 1 cent will lead to increase of how much? 7.7 by 150. So this is like this. Um, can you see my white screen?
Yeah.
So 150-cent increase in price led to a change in rating by 7.7. Yeah.
Yeah.
So 1 cent will lead to change in rating points by 7 point, equal to 7.7 by 150.
Yeah.
Here the question is how much $0.1, meaning 10 cents, will lead to change in rating point. So it will be 7.7 divided by 150 into 10. Yeah.
Yeah.
So I will knock off these two zeros. It's 7.7 by 15. It's almost like a half, right? 7.5 by 15 will be 1 by 2, point 0.5. It looks like zero point 0.5, right? Close to, very close to zero point 0.5. Yeah.
Yeah.
Don't say yes if you don't agree with me, okay? Do you think
Okay.
at
Yeah,
7.7?
no, I put it into the calculator and it came around to like 0.5.
Yeah, it'll be that only. 7.7 by 15 will be half only, close to half. Because 7.5 by 15 will be exactly zero point 0.5. So it is little less than that. A little more than that actually, 7.7. Okay. So based on that, my options are 1 and 5 will not be close. Okay. It's either between zero point 0.1 or zero point 0.5, like you said. Okay. Now, zero point 0.1 is also looking out of question. Okay. Because my value is coming close to zero point 0.5, little more than zero point 0.5. So I will probably go with zero point 0.5. But
Yeah.
in math, there's no probably, right? Let's look at one more data point. Okay. So what
Okay.
you can do is, see, this one is close to 1. Let's look at the bottom one. This is this one. Okay. And let's look at the other one which is somewhere in the middle, near the 4. Do you see the one at 4? Yeah. The third dot on the
Yeah.
line near the 4. So
Yes.
here I will make a further close guess saying, okay, the bottom one I will not say zero point 0.8. I'll say let's say it's 1. It's somewhere around 1. 1 to 4 it goes, meaning three rating points it increases. For how much increase in the price? Almost 1.2. It goes to maybe 1.7. Yeah.
Yeah.
So 1.2 to 1.7. That's what it looks like. So point 1.2 to 1.7. It goes, my price goes from 1.2 to 1.7. My rating goes from close to 1 to 4, right? This is price, and rate, this is rating, goes from close to 1 to 4. See, our reason for doing this is we're trying to see based on line of best fit what is the average increase for every 10 cents. Our earlier answer is zero point 0.5. We are guessing this is the answer. We are just validating it here. Okay. So when my price goes from 1.2 to 1.7, meaning it it increases by zero point 0.5 dollars. My rating increases by 3. Yeah.
Yeah.
Meaning 50 cents leads to increase of 3 points. 1 cent will lead to increase of 3 by 50 points. 10 cents, that's what is the question, will lead to 3 by 50 into 10. See, again, it's 3 by 5. 3 by
Yeah.
6 would have been zero point 0.5. It is little less than that. So I will still go with zero point 0.5. That looks to be the right answer. Yeah.
Yeah.
So here's the deal. I would not do the same thing with every question. Okay. Whenever you have a close fight, when you are kind of missing it by a little bit of difference, that is when you will use this technique to pick another data point and validate, because every calculation you do is going to take time, and SAT is all about being very sensitive about time, right? So I would not probably look at five different points to validate it. In the first go itself, if I got a difference between point 0.1 and point 0.5, I mean, I saw no comparison between point 0.1 and point 0.5. My answer was, let's say, close to point 0.6 or point 0.5, point 0.5. I'll probably tend to settle down with point 0.5. If my answer comes somewhere on point 0.2 or point 0.225, and then I'm debating between point 0.1 and point 0.5 as an answer, then I will pick another point to validate that. Okay. But otherwise, in general scenario, you would not do that, because that will take a lot of your time, which might not be a great idea. Yeah. Are
Yeah.
you? Yeah. So here, whatever we did, right? We just read the question again couple of times, and that gave us the clue. I will leave you with this question. Let's see if you want to try this one, and then we'll see. So we are probably not picking up another topic today, but let's make sure that we don't get any. See, the data representation thing, bar charts, pie chart, and all those are straightforward ones. I had my doubt with the scatter plot. That's why I picked up these questions to solve today. Okay. Or do you want to do this, or we can actually go to the next topic? Let's go to the next topic. I will give you some sums that you can do, and that will kind of make sure that we practice these ones offline. Will that be okay?
Okay.
Yeah.
Yeah.
So let's go to the next chapter: linear and exponential growth. All right. So linear and exponential growth. Let's spend few minutes on this one. Let me again. This chapter is about linear and exponential growth. So 1, 2, 3, 4, 5, 6. So let's say these are the number of years that I work, and on the y-axis I have, this is my bank balance, how much dollar I have saved. Okay, 100. This is 200. This is 300. This is 400. Let's say after first year, after completing 1 year of my job, I had saved $100. After I completed 2 years, I saved maybe $150. My expenses increased. I started enjoying my salary, so my saving came down. But yeah, I saved $150. Maybe after 3 years, I was able to save $200. Okay. After 4 years, I was able to save $250. What you see here is it's a it's a more predictable growth of my saving potential. Okay, year over year. Now you look at this. Come on. 1 year, 2 year, 3 year, 4 year, 5 year. Now my saving is $100 to $400, $1,000, $2,000. Who joined? Okay. Ishan, you're a little early. Please join after 7 minutes. There's a class going on for high school kids. Okay. After 7 minutes. Join at 4.
Okay.
Yeah.
Um. Okay. Bye.
Right. Okay. So here, after first year, my saving was $100, and then I went on a rampage. Second year, my saving was 400. By third year, 1,000. By fourth year, 2,000. What happened? This is called, this is when you say this, my things are increasing exponentially. My saving is increasing exponentially. So the difference between the two graphs that we saw, where there's a more linear, which is growth in straight line, a more predictable growth, and the second option is where my growth is like a curve, like a parabola. Okay, right? So this is called exponential growth. Now, other example would be, let's say, simple interest and compound interest. What happens with the simple interest? You every year, let's say, I have put $100 in bank, and my bank gives me $5 interest every year. This remains like a straight line. Now think of a compound interest where after every year my principal plus interest becomes my new principal. Yeah. Then if you look at my value, that will change. That becomes, that starts to grow much faster because every year my interest plus original principal gets combined together to become the new principal, and then the interest gets applied on that new principal. So that becomes more like a exponential growth. So in mathematical terms, you say, right? Whenever you're talking about anything in the form of this, like a slope intercept form, where one variable changes based on the second variable in a linear way, like a line, when it plots a line, straight line, that is called linear growth, meaning this and this are constant. And this is, if the value of x is changing, value of y is correspondingly changing in a linear way. Okay. So that's called linear growth. So what are the examples of linear growth? Very simple. Adding, subtracting by a common number is linear, or even multiplying. So here we are adding, multiplying by a common number, or it's not simple calculation. That is an example of a linear growth or linear equation. So basically, linear is beat linear growth, a beat linear equation. This means the same thing, where your value changes with elapse of time or against the change of another value in a more linear way, where it plots a straight line. Okay, when you plot y and x on the no, on the coordinate plane, it will represent a straight line. That's what is linear growth. All the simple calculation, with single power, I would say, where you talk about this power of a variable is here's one, here also one. Both the variables have exponent as one. That represents a linear growth in the form of a linear equation. When you plot it, it will make a straight line. That's called linear growth. Okay, that represents linear growth, or no, which is analogous to the linear equation that we know of. Quick question to you: am I creating more doubts, or am I making sense?
It makes sense.
Okay. Now, same way, when you talk about exponential growth, growth is always a function of something. Let's say if I put money in the bank, I get interest, my money increases. So my interest is a function of how much money I'm putting in the bank. Correct? Similarly, any student will get a good or bad score depending on how much effort he or she puts, how much he or she studies, how much he or she prepares. Okay, I'll have to ask the kids to join a little bit later. Um, who has joined with Mastek Mastek?
Oh, it's us. It's just
Okay, so Goshika and Ishan, sorry, Kavyan, just give us 5 minutes. I'm wrapping up the other class
okay.
with Dhanushi. So you guys can stay on mute, or you can join after maybe 3 4 minutes. Okay. Yeah.
Okay.
Yeah. All right. So coming back to the exponential part, right? I mean, I was saying that uh, the example that I was giving, right? I mean, more you study, more numbers you get, better grades you get, or more money you invest in the bank, more returns you get, or more interest you get. So one value changes based on the other value. Okay. So that is always a relatable thing, and that's what we saw with the linear equation, or linear growth also. But
Okay.
here one value is changing based on the other one. Okay, I'll have to ask the kids to wait for Ishan. Just stay muted for 3 4 minutes. Okay, I'll finish this class and then we'll start.
Okay.
Yeah. So here, the value of x is changing based on value of y. But the only thing that we noticed with the linear equation, or linear growth, was that both the variables had a maximum power of 1. Now, whenever you deal with something like this, ax squared plus bx plus c equals 0, or y equal to, let's say, ax squared plus bx plus c, meaning the maximum exponent of the variable which is leading to a change in y is more than 1, that is when it represents an exponential growth scenario. I'll probably park it here, okay? Because otherwise I'll be rushing for a lot of things, and then the kids will keep on joining. So that might make it more confusing, right? So only takeaway right now is there are two things that we're talking about: linear growth and exponential growth. In simple way, if you want to remember this, linear growth is something which can be represented by a linear equation, like the the slope intercept form that we have seen, y equal to mx plus c. And exponential growth is something which where the growth is much more rapid, much more faster, and that you cannot represent by a linear equation like this. You'll have to represent it with something which has power more than 1. Okay, so an exponential growth can be represented by a exponential expression like this. Okay, where the power of x is more than 1. I mean, it can be 2, it can be 3, it can be 4 also, but most of in up to the high school we deal with equation with power 2. So that's what we'll deal with. Okay, so that is where we'll park. I know it was a short one. So in terms of assignment, we'll do some assignments on the data representation and scatter plots, and we'll try doing some assignments on linear exponential growth also, and see if there's something more that we need to learn as part of this, or whatever we have seen so far is good enough. Okay. Yeah, Dhanushri?
Yeah.
Okay. All right. So wait for the assignments. I'll send it to you in not couple of days, maybe by tomorrow or day after. And then
Okay.
try doing it and see if we need something to be clarified before we move on. Yeah.
Yeah.
All right. Thank you so much, Dhanushri. You can drop off.
Okay.
You
Thank
with
you.
younger ones. Yep.